Hello everyone, my name is Abhishek and welcome back to my channel. Today is the very first episode of GCP Zero to Hero series, and in this episode we will focus on fundamentals of cloud computing and introduction to Google Cloud Platform. So in detail, we will understand what is cloud computing, why cloud computing, what is Google Cloud Platform, in which aspects is Google Cloud Platform better than AWS and Azure. Then we will learn how to create a free GCP account and how to best utilize the free GCP account. So we will understand which services are part of the free account and which services are not part of the free account. Then we will also learn how to access the GCP console and how to access GCP resources using Cloud Shell. In today's video, you will also get familiarized with common cloud computing terms. So this is a vocabulary which is used in cloud computing. And by the end of this series, you will master each and everything that is present in this document. However, in the first episode, you will get familiarized with this vocabulary. So I will try to explain each and everything in one line. This is going to be a very interesting video. Make sure you watch it till the end. Now, before we get started, there are two things that I need to talk about. First is this documentation. So for the entire series, each and every episode documentation will be shared through this GitHub repository. GCP Zero to Hero, you will also find the GitHub link in the description. After watching every video, you can go through this MD files and revise what is explained in the video. This is a public repository. You can just poke it, you can just star it. Second thing, the entire GCP series will be covered as part of 20 episodes. It can be 21 or 22 as well. And in each episode, I will introduce you to a topic and I will explain the GCP services for that topic. If possible, we will also do demonstration of those services. So by the end of this series, you will definitely master Google Cloud Platform. Let's start with understanding what is cloud and why is cloud very popular. To understand this better, let's go back to 2010 and just imagine there is a company called Flipzone. Flipzone is planning to sell products online. So basically, Flipzone is planning to be one of the e-commerce companies. Developers at Flipzone started building that application. Maybe after a year, developers at Flipzone have built that e-commerce platform. It is deployed onto their personal machines. They have tested it on the personal machines and they said the platform is ready to go live. They also shared the steps with QE. QE also deployed the platform or application onto their laptop. They tested it thoroughly and they said, perfect, the platform is ready to be live. Flipzone is quite excited about it because they are happy. The products can be viewed by customers. And if they like the products, they will also start buying the products. However, Flipzone cannot make the application live from developer's laptop or QA engineer's laptop because one, laptop is a personal machine. For some reason, if this gets shut down, that means customers cannot access the application. Two, laptops usually come with limited computing power. Maybe back in 2010, a very good laptop might have 4 CPU, 4 GB RAM. This is good for tens of users, but if the platform becomes popular and if hundreds of users start buying products on Flipzone, this is definitely very, very less, because of which customers will find downtime with the application. And for other obvious reasons, FlipZone should deploy application onto server, but not the personal machines. In fact, your laptop is also a server, a sophisticated server with good features. However, a physical server that we're talking about, comes with extended compute power, or it comes with more compute power, typically much more when compared to your laptops. Maybe this server that you buy might have 100 CPUs, 100 GB RAM, 10 TB of storage. And this server, through some switches and cables, can be connected to the internet. So once you deploy your application onto the server with some proper networking configuration and with some proper firewall configuration, this can be connected to the internet so that external users can access the FlipZone application, deploy to the server, and purchase the products. But the big challenge again, okay, FlipZone can deploy the application onto the servers, but from where can FlipZone buy these servers? Back then, the popular choice was HP, IBM, and few other vendors. Now, when FlipZone purchased the server from, let's say, IBM, it is not done because to maintain the server, they need a system administration team. So now, along with developers and QE, FlipZone also need a system administration team, because this system administrators, they procure something called server racks, and on these server racks, they organize the servers. A lot of times, a single server is not enough, typically when you have multiple applications. So you might procure multiple servers from HP or IBM, and these servers are organized within the server racks using some switches and cables, as I told you. These servers are connected to the network through which applications deployed on these servers are accessible by the end users. And this setup is called as a data center. So back in 2010, even typically when I started my career, every company used to have their own data center. So even if it is a small company, let's say a company which is running on a single floor, typically they used to have their server rooms, which can also be called as data centers. Data centers are usually big server rooms, but anyways, when you have bunch of servers, you can call it as a data center or a server room. Now, maintaining this server room comes with a lot of challenges. Okay, FlipZone can procure a server. It is not that difficult. But setting up the server room or data center, along with that, maintaining this data center. Abhishek, what do you mean by maintaining the data center? For example, data center should be set up. It has to be a very sophisticated setup with proper temperature all the time. Then the data center has the servers. These servers, operating system should be installed on these servers. For example, just like your laptop has Windows or Mac OS or Linux, these servers should also be installed with an operating system. Only then application, which is software layer, can interact with the hardware layer of the server. OS acts as a medium between software and hardware. So these system administrators should install operating system on all the servers. Now, once the operating system is installed, that operating system has to be maintained. You cannot have the same version of operating system throughout. As you keep upgrading the operating system of your mobile, similarly, you should also upgrade to make your server free from security vulnerabilities. Then these servers are also should be timely maintained. So HP or IBM, there has to be a contact with them on timely basis. The servers also have to be maintained for maintenance. Along with that, the network, switches, cables, all these things have to be taken care by system administrator. Now, this becomes a huge responsibility. Imagine developing an application is less than half of an effort, but setting up the data center, maintaining the data center, deploying application to the data center. All this is more than half of an effort. And every company used to go through this pain. Typically till 2010, 2012, 2014 even, lot of companies used to have system administration team and they used to maintain all of this. Now, if you consider this as a challenge, there is another challenge, that is cost. Let me explain this with a simple example. Today, if you buy a laptop, you always consider maximum utilization. Maximum utilization becomes your primary criteria. So that means when you buy a laptop, you always think, okay, what can be my maximum utilization? Maybe while I'm playing a game, along with that, while I'm playing some music or while I'm watching a movie, what can be number of CPU, number of GPUs that can be utilized by my laptop? Maybe you might come with a figure called, okay, at maximum, I might use 4 GPUs, I might use 12 CPU and 32 GB RAM. Now you buy your laptop with this specification. However, you would use this maximum specification or you would use the maximum resources, maybe 1 by 10th of your entire laptop utilization. Or maybe for 1 hour of the day, you might utilize your laptop to the fullest, but rest of the 23 hours, you will not be utilizing the resources. Typically, you will underutilize the resources. And when your laptop is shut down, so you are utilizing 0% of your resources. But still, when you buy the laptop, you pay for this entire specification. Now, because this is your laptop, which is not that expensive, you are not really worried about it. But imagine when a company procures 100 servers from IBM, let's say, and each server that they procured from IBM, so IBM says we have standard size of the server and the minimum that we can offer as a physical server is 100 CPU, 100 GB RAM, just for example, 10 TB. Now this company says I need 100 servers. So they have taken almost this specification into 10 times. At 1 a.m. in the morning, because there are no customers for their e-commerce platform, the resource utilization will be absolutely not zero, but maybe 10%. Because still some processes are running, your application is running, although there are no end users. So you might utilize 10% of the resources at 1 a.m. in the morning. At 2 a.m. in the morning, same. At 6 a.m. in the morning, this number might come to 20. And 10 a.m. to 11 a.m. in the morning, which is your peak hours, let's say, your system might utilize 70 to 80%. But rest of the times, even though you're not utilizing the resources, because you bought that server, because you bought that number of servers, you have already paid the IBM or already paid the company. Now, these are two primary challenges which cloud aims to solve. The first company that introduced the concept of public cloud was Amazon. So Amazon said, okay, you don't have to worry. Like every startup is going through this pain. Every mid-scale company is going through this pain. So what we will do, no, we will set up data centers across the globe. So Amazon said, we will have our data centers in the United States, typically in multiple parts of US, US East, US West. We'll also have our data centers in multiple parts of Europe, multiple parts of Asia, and Australia. Now, any startup can approach us. We will be maintaining these data centers. As I told you, what is data center? A big server room with multiple servers. Amazon said, we will do it at a very, very large scale. So we will have our data centers with thousands, 10,000s of servers. Any startup can reach out to us if they have their base in United States. So they can go to Amazon platform, which is called as Amazon Web Server. They can go to the platform and they can request for, let's say, 2 CPU 2 GB RAM. And what we are going to do within this huge data center, we will give them 2 CPU and 2 GB RAM. Rest of the resources we will share with other company. So this way, multiple companies can share our data center, or multiple companies can share the resources of our data center. And this is a win-win situation. So startup, they don't have to maintain the data center. Us, we will maintain the data center, but we will charge you for the resources that you are utilizing. And because we deal with multiple companies, we will ensure all the resources in our data center. If we have 10,000 CPU, we will ensure all the 10,000 CPU is utilized. At least maximum amount of CPU is utilized. So this way, it's a win-win situation. Now, but Abhishek, you might ask, how does this include cost saving? Okay, now Flipzone, they don't have to maintain their data center. They can just go to AWS or Amazon's cloud platform, and they can request for required amount of CPU and GPU, which is perfectly fine. For them, they don't have to maintain the data center. But how is this cost saving for Flipzone? Because the second challenge that we talked about was cost. Now, this is a huge saving in terms of cost as well, because what you can do with these cloud platforms, it can be Amazon, Google, or Microsoft's Azure. You only pay for what you use. That means 1 a.m. in the morning, you can request for 2 CPU, 2 GPU, or 2 GB RAM. You will be charged for this exact amount. 2 a.m. in the morning or 6 a.m. in the morning, you can say, I need 10 CPU, 10 GB RAM. 10 a.m. to 11 a.m. in the morning, you can say, I need 60 CPU, 60 GB RAM, or I need multiple machines with this configuration. You will be only charged for that particular configuration. And you can dynamically change it. Like you can say at 1 a.m. I need this, 6 a.m. I need this, 10 a.m. I need this. You can dynamically change the required configuration, and cloud provider will be costing you only for that particular configuration. So for this hour, they will be charging you X amount. For this amount, they will be charging you Y amount. And for this hour, they will be charging you Z amount. So this way, because of cloud platforms, companies like Flipzone, typically every company after 2010, I should say majority of the companies after 2010 started using cloud platforms, and they started taking the benefit both from maintenance point of view, the data centers maintenance, and cost point of view. Now, what these companies like Amazon do is called as cloud computing. So Amazon's AWS is called as cloud computing because they are using these resources, their existing resources, and they are offering the services. It can be compute, it can be storage. Now, Amazon offers various services, but initially it started with compute and storage, also networking. So this process of cloud providers, or the model that involves in the delivery of the computing services, instead of companies owning their physical services or physical resources, is called as cloud computing. Don't worry about the definitions, because we have these MD files which typically explains the definitions. You can go through this after watching the video. For now, focus on understanding the concept. So this is called cloud computing. And after Amazon, companies like Microsoft started Azure, and Google started something called Google Cloud Platform, which is our focus for this entire series. So Google's Google Cloud Platform is what we are going to learn. But now you might ask, Abhishek, when there is AWS, when there is Azure, already serving the customers, already helping with the cloud, why should one go with GCP? So GCP has a unique selling point when compared to AWS and Azure. That is, they have tested their cloud platform, or they provide scalability and performance as their unique selling point because Google's services like Gmail, Google services like YouTube today run on Google Cloud Platform. So that means there is already a proof of concept for people who want to use Google Cloud. So Google can say, hey, don't worry about the scale. We have tested Gmail or we have been running Gmail on Google Cloud Platform. We have been running YouTube on Google Cloud Platform. Today, if you look at concurrent number of users, I don't think any other company would have a larger user base when compared to Gmail or YouTube. So it's a tested cloud platform for scalability and performance. So this is a unique selling point of GCP. You might ask about features, but Abhishek, are there any features as unique selling point? I wouldn't call features as unique selling point because cloud providers are pretty competitive. Today, if GCP comes with a particular service, maybe in a couple of months, you will see AWS and Azure launching the similar service. Implementation might change. How Google offers Kubernetes service, how AWS and Azure's offer those services might be different, but mostly cloud platforms offer same services or similar services. So the competition is not with the features, but the competition is with respect to implementation. Competition is with respect to scalability, performance, and security. Great. So now you have understood the difference between AWS, Azure, and GCP. You also learned what is cloud. Now you might ask, Abhishek, what is this public cloud, private cloud, and hybrid cloud? I read about different types of clouds. What exactly is the difference between them? Whatever we learned till now in this lecture is basically public cloud. So Amazon, Azure, Google Cloud, maintaining their data centers across the globe, offering cloud computing or offering services on their own platform is called as public cloud. And typically anybody can sign up, create an account with these platforms, and they can start using these services, not running anything at their end. As an example, we looked at Flipzone. We talked about Flipzone. Now, what is private cloud? The example of Flipzone is a startup, but let's say there is a bank, right? Let's say there is a very popular bank in United States. Now, this bank might not be comfortable sharing their user data with AWS, Azure, or GCP. Bank might say, we really like the concept of cloud, but we don't want to share our data with the public cloud platforms. So what companies like, typically banks or financial institutions, what they can do, they can procure multiple servers from IBM or HP. Today, there are a lot of companies which sell servers. They can set up their own data centers across multiple regions if required, right? They can set up one of their data center in East United States, in West United States, or if it's a small company, they can only set up one data center and they can have their own system administration team. As we discussed, what companies used to do back in 2010. So they can typically maintain their own data centers. They can configure their own networking. They can set up their own firewall configuration, allow few people to access the application, blocks for some of the users. They can maintain the compliance. And this setup is called as private cloud. Or people also call it as on-premises. Most of the companies used to do the same thing before 2010. 2010 is just a reference point. Every company did not switch after 2010. The evolution of cloud computing has taken good amount of time. Now, what is hybrid cloud? So hybrid cloud is a concept. This has been evolving from last 6 years, 7 years, where now the concept of hybrid cloud is that, let's say this bank company, or let's say a bank institution. For bank, not everything is sensitive. Of course, their customer data is sensitive, but bank might also have some applications or bank might also have some data which is not very important. Like, it doesn't matter if this uh, data or this data is not as secure as the customer user base. So what banks can do, they can continue to maintain their private cloud, or they can continue to have their on premises setup. Along with that, they can also have an account in public cloud where they can run the non-important or non-sensitive machines or non-important data they can store on the public cloud platform. So public cloud and private cloud, using them in combination is called as hybrid cloud. Typically, some banks started following this approach. Some financial institutions started following this approach where they have their sensitive information even now on their on premises, like database or their queuing service or their data streaming service. They have all of them on the on premises, and the non critical information may be information related to some files within the bank that are not related to the users, or information that is about the policies of the bank which are public to the users, everything that you see on the internet, right? So these things can be on the public cloud platform. So this way, banks can save some money, and they can also slowly offload the effort of their system administrators by reducing the size of their data center or reducing the size of their server room. So this is the concept of hybrid cloud. Mostly today, 90% of companies, they go for public cloud, and rest 10% is between private cloud and hybrid cloud. Typically, if you're talking about startups, it's 100% of them or 99.9% of them go with public cloud. So this is the difference between public cloud and private cloud and hybrid cloud. So what did we learn till now? We learned what is the concept of cloud. We learned what is cloud computing. We learned what is the difference between AWS, Azure, and GCP. As I mentioned, when you look at features, every cloud platform starts offering or they mimicking each other's services. So it's not about the features, but it's about performance, scalability, and security. GCP has a unique selling point because the services like Gmail and YouTube, they run on Google Cloud Platform. Of course, other cloud platforms also have their USPs. And we also learned about the difference between public, private, and hybrid cloud. Now let's go ahead and see how to create an account with GCP. I'll also show you how to best utilize the platform. As we go ahead, you will learn more about it. But in today's video, I'll give you a quick synopsis on how to best utilize your free account. So for that, all that you need is a Google account. I think every one of you might have a Google account because every one of you use Gmail, every one of you use YouTube. That means you have a Google account, right? Now, GCP can be used in two different ways. For your hobby or for your practice purpose, you can use your Google account, and using your Google account, you can create a free account. But when it comes to enterprise, I will discuss more about the GCP hierarchy in the next episode. You will learn more during that time. But for now, when you're working in enterprise, instead of Google account, you use something called as Google Workspace. And using Google Workspace, you create a organization which you cannot create in the free account. In the free account, we will create projects, and within projects, we will create resources. Whereas when you go with Google Workspace, you can create an organization within which you can create folder, within which you can create projects, and within projects, you can create resources. If you did not understand this part, don't worry. In episode 2, we have dedicated lecture on this. what is organization, what is folder, what is project, what is resources. But just for the context of the video, I have explained it. So every one of you must have a Google account, just like I have this Google account. So using this account, click on start free. But Abhishek, where should I search for it? Just search for cloud.google.com, right? Cloud.google.com and click on get started for free. Here on this page, you can also see what do you get with the free account. This is very, very important to read. I would say spend some 10 to 15 minutes on this page, cloud.google.com. So you get $300 of free credits. So if you create an account with GCP, you get $300 of free credit as a new customer. You also get some free services. So these are the free services that you get. You get a compute engine with one E2 micro instance per month. If you create two E2 micro instance per month, then you will be charged. But Abhishek, what is this E2 micro instance? I will talk about it in episode 4. So this is basically a server that you can get from GCP. So this is the capacity that you can get for free, which is one CPU, 1 GB. Beyond that, even if you create two of them, you will be charged. Cloud storage. So you get 5 GB per month standard storage. Beyond that, you will be charged. BigQuery, Cloud Run, Google Kubernetes Engine, all of them are part of the free services, but only to the limited extent. This is where a lot of people, they incur cloud charges. They say that, oh, okay, we have used the cloud platform, but we are being charged even with the free account. That is because, that happens when you are utilizing the resources beyond the capacity that is offered in the free tier. You cannot create 100 servers on Google Cloud Platform and expect Google to offer it for free. No, they offer only limited things. Beyond the limited, you will be charged from this $300. Let's say you have created two instances. One instance become free and other instance, whatever charge it is, let's say $half per day or $1 per day, that will be deducted from $300 that is offered to you as part of your free account. And beyond that, what happens? You will be charged. Of course, any cloud platform, what they do, they ask you to pay. They don't directly deduct from your bank account. At least GCP, AWS, they don't directly deduct from your bank account. They ask you to pay for it. Okay. Now, get started for free. So you have to provide these basic details. Which country are you in? Okay, I'm in India and I'm using one of my Google accounts. You can follow the same steps. A good thing about GCP, it also provides UPI as an option. At least I haven't seen that with other cloud platforms. If you're in India, individual, you can provide your address, at least provide the state that you are in. Okay, let me provide something. So I'll just say perfect. And I will give one of the pin codes. Create. Perfect. Now learn GCP, pay with net banking, or do you want to pay with UPI QR code, or do you want to pay with credit or debit card? So this is what I was talking about. Mainly, I haven't seen companies or cloud platforms offer payment through UPI. It makes students or working professionals without credit card, let's say, their lives easy. So you can proceed with UPI payment. If you're outside India, you can definitely go with debit card or credit card and any other options that show up for you. Okay. Start for free. So I'll proceed with this particular payment and I'll pause the video here. Once my payment is done, I will resume the video. If one of your payments does not go through because of some reasons, maybe not enough bank balance, or maybe for some reasons, you can switch between the different payment options. Okay, so how would you like to get started? Learn to use Google Cloud. That is what we are going to do. Perfect. How would you like to get started? Create AI solutions. We'll mainly focus on build and deploy web and mobile applications. Of course, we might take a look at their AI solution as well, but yeah. So now this is the free account. Free trail status, 25,000 credit in 91 days. Activate your full account to get unlimited access to Google Cloud Platform. So what we need to do? We should activate the account. Keep your cloud running uninterrupted. Pay only for what you use. Keep any remaining credits to spend during the free trial. Okay, so I will activate my account. Perfect. Now, one thing that I wanted to tell, it depends on country to country. In India, when you create a Google account with Google Cloud, my bad, a standard instruction is set up with your bank. So typically what I do whenever I'm learning GCP or whenever I'm learning Azure, it is same with Azure as well. I just remove the standing instruction because, somewhere back of the mind, it keeps bothering me that a standing instruction is set up. And if I do something wrong with the cloud platform, maybe if I overutilize the resources beyond my free usage that is offered, I might be, or GCP might incur charges and it might take money from my bank. Of course, that's not the situation, but still, I just remove the standing instruction. So you can also go ahead and do it. It's not a big thing. You can just check with your bank and get your standing instruction removed. Perfect. So you have activated the full account. So now we have learned how to create an account with Google Cloud as well. And there is something called Cloud Shell here. So once you have your account activated, you can, of course, navigate and utilize the resources on the Google Cloud. Along with that, you can also use the Cloud Shell. So from this terminal, it's just like terminal on your local machine, like command prompt or git bash on your local machine through which you can connect to the cloud platform. Instead, you can actually authorize the Cloud Shell here by just signing up your account, and using this Cloud Shell, you can interact with your cloud platform through some CLI commands. What are those CLI commands? They are gcloud CLI commands. We will learn about the gcloud CLI commands as we proceed with next videos of your series. Advantage is that you don't have to install gcloud. You don't have to install the basic things on this Cloud Shell environment that is provided to you. On your laptop, you have to install gcloud. You have to configure gcloud with the credentials, which can be eliminated if you use Cloud Shell on Google Cloud Platform. Right? We will be using both gcloud and also terminal on the local machine. Don't worry about it. Now you can search for compute engine and you can create a server, which is typically a virtual server on the cloud platform, or you can create storage on the cloud platform. You can request for HDDs, you can request for SDDs, right? SSDs, my bad. Everything by enabling the APIs. How to enable these APIs, how to use these resources, we will learn as we proceed with next videos of the series. But for today, I hope you learned how to create an account. I hope you learned about cloud computing, what is the difference between AWS, Azure, and GCP, and various other concepts. Finally, let me introduce to some popular vocabulary. Whether you are learning AWS, whether you are learning Azure, whether you are learning GCP, this is some vocabulary that you have to get used to. Of course, on the first day, you might not understand all of these terminologies, but I just want you to get familiarized or get used to these terms. First one is virtualization. Now, if you want to stop this video at this point, take some break, you can definitely do it because I know this is a lengthy video. Once you resume, you can start understanding these terminologies. First one is virtualization. Now, what is virtualization? Sometime maybe 5-10 minutes back, I told you that on the cloud platform, AWS creates or GCP creates data centers across the globe. I told you companies like Flipzone, they can request for 2 CPU, 2 GB RAM. And within the data center, cloud platform like GCP offers the exact resources that they are looking for. But how is this possible? Because even Google Cloud has to buy huge servers, let's say 100 CPU, 100 GB RAM. Now, if Flipzone is requesting resources, let's say they have 5 different servers on their data center, just for example. If Flipzone is requesting for only 2 CPU and 2 GB RAM, if they dedicate this entire server with 100 CPU, 100 GB RAM for Flipzone, what about rest of 98 CPU and 98 GB RAM? Are those resources wasted? No. So cloud platforms use a concept called as virtualization. So on each of the server, or maybe as a layer on top of all of these servers, they use a concept called virtualization. And using this concept of virtualization, they break the physical servers into multiple virtual servers. Now, when Flipzone requests for 2 CPU and 2 GB, request goes to virtualization platform of whatever is used by Google Cloud. And this virtualization platform, it creates 2 CPU, 2 GB RAM of virtual machine on the physical server, and then it shares that information with Flipzone. Virtualization is, somewhere I explained it at a surface level. It's not that easy concept, but overall, this is the synopsis. So request goes to the virtualization layer. It creates a virtual server on top of the physical server. And this virtual server SSH access is granted to the engineers at Flipzone. And other virtual servers are shared by other companies or maybe other requests that are sent by Flipzone. So virtualization is a process of breaking down physical server into multiple small virtual servers. We have complete video on virtualization. If you are interested, you can go through it. So as I told you, what is a virtual machine? It's a software-based emulation of physical server, typically a small virtual server on top of your physical machine. API, another term that we will be using throughout the series. What is API? API is application programming interface. Just a couple of minutes back, you might have seen Compute Engine API. So whenever you are interacting with Google Cloud, it can be through G Cloud, it can be through your terminal, you will be interacting with API of Google Cloud or APIs of Google Cloud. What does that mean? For any application in the world, there are 3 ways of accessing the application. First way is through the user interface. Second way is through the CLI. Third way is through the API. UI, you already know, just like how you go to your browser and access google.com, let's say. CLI is using command prompt or PowerShell. By running some commands on command prompt or PowerShell or iTerm, you interact with the applications. For example, you can use the curl command and interact with google.com instead of using the user interface or using a browser and interacting with google.com. Similarly, there is something called API where if you are using programs, for example, if you are using Python or if you are using, let's say, Ruby, or if you are using Golang, how can a program interact with application? A program can interact with application using the API. So a human can interact with the application using browser, that is using the UI. A command prompt or PowerShell can interact with application using CLI. A program can interact with other application using API. That's it. Now, the next terminology that we keep using is regions. As I told you, cloud providers, they create data centers in different parts of the globe. So globe is divided into multiple regions by these cloud providers. For example, what AWS says, right? For AWS, US East is one region, US West is one region, EU Europe is one region, right? Similarly, they break globe into multiple regions. That is used for easy understanding to understand where to deploy the application. So they have regions. So someone who is in some part of US, let's say they are in the east part of US, so they can create server in east part of Amazon's data centers, right? Availability zone is nothing but a data center. So what typically cloud platforms do, so they have regions. Within the regions, let's say US is one region, US East is one region. So within this, they have multiple data centers, maybe kilometers away or miles away. They set up different data centers, and these data centers are called as availability zones. Why do they do that? Maybe because of some climate issues or maybe because of some natural calamities. If something happens to one of the data center or one of the availability zones, there are still other availability zones which can serve users requests or which can serve compute requests. Scalability. Scalability is a concept where it's the ability of the system to handle increasing number of requests. Let's say your application receives 10,000 requests. Your application receives 1 million requests. So scalability is a concept in cloud computing where it is used to understand if you're going with a scalable architecture or not. So are you designing your application architecture in a way it can handle scalability? Elasticity. So elasticity in cloud computing refers to ability to dynamically scale the resources up and down. Now, this is not about your application, but this is about the infrastructure. So when you are designing a system, can your infrastructure, can your servers scale up and scale down? This is called as elasticity. Now, agility is a concept where your system can adopt the changes or not. Maybe there are changes in the user's request. Maybe there are changes in the number of requests. If your system can handle such situation, that means your system is designed to handle agility. High availability. In this world, like in 2025, you want your systems to be available 100% of times. Even if some customer access your website at 3 a.m. in the night, because it is 3 a.m. in the night, you cannot bring your system down. It should be completely available. So this concept is called as high availability. Fault tolerance. Fault tolerance is a concept where your system continues to operate even when there is some software or hardware failures. Let's say there is some compute challenges, or let's say there is some software level challenges. Have you designed your system in a way your system is fault tolerant or not? But Abhishek, how can I design highly available system? How can I design fault tolerant system? How can I design system with agility mindset? Don't worry. Today is just day one. We will learn all of these concepts in this series. Disaster recovery. Let's say even after following fault tolerant architecture, agility, elasticity, even after following all that, your system goes down. Are you in a situation to handle such disaster? Do you have backup of your database? Do you have backup of your application? This is called as disaster recovery. Finally, load balancing. So load balancing is a concept where when you have millions of requests or hundreds of requests, thousands of requests, do you have compute in multiple regions, or do you have application in multiple regions, so that requests sent from the customers are balanced between multiple copies of your application? So that is called as load balancing. Each and every feature of cloud computing we will discuss in detail. The goal of this episode is to just get you familiarized with this vocabulary. That means going ahead, whenever I say virtualization, or whenever you come across virtualization while reading the documentation, this should not look like a complete Greek word to you. That is the whole concept of introducing vocabulary in today's lecture. If you did not understand the vocabulary part, don't worry. I will make sure by the end of this series, you will master this vocabulary. So this is all we have for today's video. As I told you a couple of times before, make sure you go through the documentation. After every episode, watch the video. Once you're done with watching the video, make sure you go through the notes. And if there is any practical, make sure you implement the practicals as well. See you all in the next video. Take care. Thank you so much for watching the video. Bye-bye.